And then I just calculated today that, in fact, 3I Atlas gets near Jupiter on March 16th, 2026, at a distance which is exactly identical to the distance inside of which Jupiter's gravity dominates over the sun's gravity.
New data just dropped for 3I Atlas, and for the first time since this object entered our solar system, we can talk about it without guessing. No hype, no speculation, just real telescope images and real orbital simulation data. Look at this frame taken on November 22nd. The stars are streaked because the telescope tracked the comet's motion, but the object itself, soft, centered, surrounded by a diffuse glow. That glow isn't a solid shell, it's dust and gas, what astronomers call a coma, and that's normal behavior for an active comet. When contrast is boosted, you start seeing structure inside that glow. Brighter zones. Smooth symmetry. Some people call this unusual. In reality, it means the outgassing is balanced, not chaotic. That's important, because balanced outgassing usually means the core is rotating steadily, not breaking apart. Now look at the inverted version of the same data. This isn't showing metal. This isn't showing a ship. It's showing gas distribution patterns. There's a forward tail, and there's an anti-tail. That sounds dramatic, but it's actually a known phenomenon. Anti-tails happen when dust spreads along the comet's orbit and Earth passes through that plane. It's geometry, not propulsion. Hit subscribe. Because what comes next isn't about alien technology or government cover-ups. It's about real physics finally explaining what we're actually looking at. Independent backyard telescopes are now matching what larger instruments are seeing. The tail is still present. The anti-tail is still visible. The coma is large and diffuse. That consistency matters. When amateur astronomers across different hemispheres using different equipment all capture the same structures, it stops being coincidence. It becomes data. And the data is telling us something clear. 3I Atlas is behaving like a comet. An unusual comet, yes. An interstellar comet with chemistry we don't fully understand, absolutely. But a comet nonetheless. The forward jet that sparked so much debate, still there, but now we understand it better. It's not a thruster, it's anisotropic outgassing, jets firing from specific regions on the nucleus as it rotates. The orientation makes it look forward-facing from our vantage point. The structured coma? Not a sign of engineering. It's a sign of stable rotation and even gas release. When a comet tumbles chaotically, its coma looks messy, asymmetric, constantly shifting. When it rotates cleanly, the coma forms smooth, symmetrical patterns. 3I Atlas is rotating cleanly. A new study just ran thousands of calculations on this object's path, not testing durability, not testing structure, testing trajectory stability. They simulated how the orbit behaves when influenced by Jupiter, Mars, and non-gravitational forces caused by outgassing. These forces matter. When a comet releases gas, it creates tiny pushes like microscopic rocket thrusters. Over time, those pushes can change the trajectory. So the question was, does 3I Atlas show signs of unusual acceleration? Does its path bend in ways that can't be explained by gravity and known outgassing? Here's the result. The orbit stays coherent. The path bends smoothly. Not because the object is engineered, but because gravity is predictable and because the comet's outgassing is stable, not explosive. Every deviation from a pure gravitational path can be accounted for by the observed jet activity. The math works, the physics checks out. This is significant. Because if the object was under intelligent control, if it was adjusting its trajectory deliberately, the simulation wouldn't match. There would be unexplained accelerations, course corrections that don't align with outgassing patterns. There aren't. Go back to the spectroscopic data. 3I Atlas is dominated by carbon dioxide, not water ice. The CO2 to H2O ratio is about 8:1. That's rare for solar system comets, but it's not impossible. It suggests the object formed in a colder region of its parent star system, where carbon dioxide ice is more stable than water ice, or it spent billions of years in deep space, where radiation processing altered its surface chemistry. The nickel emissions? Still unusual, but not impossible. Nickel and iron typically appear together in cosmic material because they condense together during supernova explosions. Finding nickel without much iron suggests unusual formation conditions or extreme radiation processing. It's weird, but weird isn't the same as artificial. The thermal pulses, the rhythmic brightening in the infrared spectrum that some interpreted as a heartbeat? Real, confirmed by multiple observations, but the timing matches the rotation period. Every time the nucleus completes a spin, certain regions face the sun and heat up. Those regions release more gas, the coma brightens. It's a thermal cycle driven by rotation, not an internal power source. Anti-tails have confused observers for centuries. They look wrong. A comet's tail should always point away from the sun, blown back by solar wind and radiation pressure. So when a tail appears to point forward toward the sun, it breaks that rule. Except it doesn't really point forward, it's an optical illusion. Here's what's happening. As a comet moves through space, it leaves a trail of dust along its orbit. Most of that dust is large, slow-moving particles that don't get pushed back by solar wind as easily as fine dust. When Earth passes through the orbital plane of the comet, we see that dust trail edge on. From our perspective, it looks like a spike pointing forward, but it's not. It's a flat sheet of dust we're looking at sideways. This happens with solar system comets all the time. Comet Arend-Roland in 1957 showed a famous anti-tail. So did Comet Hale-Bopp in 1997. It's well understood. 3I Atlas is doing the same thing. The anti-tail isn't propulsion, it's geometry. So here's the real picture. Real telescope images show a diffuse, active coma. Real simulations show a stable, predictable orbit. Real spectroscopy shows unusual but explainable chemistry. That doesn't prove 3I Atlas is just an ordinary comet. It's clearly not ordinary. Its composition is strange, its behavior is unusual, its origin is from another star system entirely, but it does make one thing clear: the object is behaving according to known physics. Every anomaly that sparked speculation, the forward jet, the thermal pulses, the anti-tail, the structured coma, has a natural explanation that fits the data. Does that mean we fully understand it? No. We're still watching it, still collecting data, still running simulations. But the early panic, the claims of alien technology, the theories about engineered craft disguised as comets, none of that is supported by what we're actually seeing. 3I Atlas is a very clean, very well-behaved interstellar object, and that alone makes it worth watching. The object is already moving away from the sun. It passed perihelion in October 2025. Now it's climbing back out, accelerating as it escapes our solar system forever. Every day it gets dimmer, harder to observe, harder to track. Within months, it will be too faint for most telescopes. Within a year, it will be gone. It's a messenger from deep time, carrying information about how planets and comets form around other stars. And the fact that it's behaving so consistently, so predictably, according to known physics, is actually more remarkable than if it were something artificial, because it means the laws of physics are universal. Comets and other star systems form the same way. They behave the same way. They follow the same rules. 3I Atlas isn't breaking physics. It's confirming it. This is where we're at right now. Not guesses, not sci-fi. Just real data finally catching up with the hype. The next few observation windows could sharpen this picture even more, but the broad strokes are clear. 3I Atlas is an interstellar comet with unusual chemistry, stable rotation, and predictable orbital dynamics. It's strange, it's fascinating, it's worth studying, but it's not what the early speculation claimed. And that's okay, because what it actually is, a pristine sample of another star system's planetary formation, is more scientifically valuable than any imagined alien probe. We're watching a visitor from another world, not in the sci-fi sense, in the literal, astronomical sense. An object that formed around a different star, traveled for billions of years, and arrived here just in time for us to see it. That's extraordinary enough.